machine works. On one side, you have your inputs, a set of buttons. Let's call them set A. On the other side, you have your potential outputs, the snacks. That is set B. When you press button 1 and a bag of chips drops out, you create a connection between the two sets. In math, we write this specific connection as an ordered pair. If we map out all the possible button presses to their specific snacks, we get a collection of these ordered pairs. We call this complete list a relation. A relation is simply the mathematical rule describing how elements from one group connect to elements in another. Let's give these sets proper names. Starting inputs, the buttons, form the domain. Possible outcomes, every snack stocked, is the codomain. Items that actually drop out make up the range. An undispensed chocolate bar exists in the codomain, but isn't part of the range. The range is always the specific group of realized outcomes, living inside that larger bubble of possible outcomes. Now we need to separate standard relations from a special, stricter category called functions. To do this, we use the golden rule. Every input must lead to exactly one output. This mapping diagram from your textbook shows a perfect scenario. Each number in set X points to a single, unique value in set Y. This machine is well behaved. It is a function. But look at diagram B. If you input the number 1, the arrows show it might give you a -1 or a 1. A machine with unpredictable results fails the test. A single input yielding multiple outputs means this is a relation, not a function. Here is another broken machine in diagram D. Look closely at the number 1 in set M. It has no arrow at all. If an input does nothing, the rule fails again. Every domain element must be used. Empty inputs mean it is not a function. Now, consider a case where pressing button 1 drops a bag of chips, and pressing button 2 also drops a bag of chips. This perfectly follows the golden rule. Two distinct inputs can lead to the same output, provided each button does exactly one predictable thing. Let's test this. Here are two relations in roster form. Look at the ordered pairs and figure out which one is a function. The second relation, R2, fails. The input 1 maps to a 5, and then that same input 1 maps to a 6, giving unpredictable outputs. The golden rule is universal. Whether tracking arrows on a diagram or scanning coordinates, every X value can only have one Y value. To summarize, when you look at a set of ordered pairs, the first numbers, the X values, make up your domain. The second numbers, the Y values, make up your range. To verify if your relation is a function, just run through this checklist. Make sure every single input is used, and make sure no input has split arrows. These coordinate graphs show what happens when we take these ordered pairs and plot them. Once you understand the golden rule, you can spot a function instantly on a graph like this, using something called the vertical line test. We will cover exactly how to do that in our next lesson.